And the amount of hacking we see against websites in the last few years has only increased. Just in the last year or two, we've seen some incredibly high visibility attacks where SQL injection attacks were used to steal password data from very high visibility websites. And these attacks are not stopping. And we see an increase in the attacks on both web applications and web services. There have been several social networks that have been hacked. And one of a very large social network, a business social network, was hacked through a SQL injection attack. And the attack was used to steal database data. And the attacker specifically got the password field in the database and then released this list of passwords to a public website where many people could see the username and the password for all of the users of this very popular website. Number one, the code was not protected from SQL injection. There's a defensive technique a computer programmer can use called query parameterization. It's easy to use, and it really protects your application from SQL injection attack that's used to steal data. The other vulnerability was poor password storage. This is a poor use of crypto. When you store a password, you want to store that password in a way that even if the attacker steals the database, they can't reverse or figure out the password. Sometimes it's just for the fun. Attackers can do it. They try to do it, and they do it just to prove that their capabilities are strong, that they're a good hacker. Now, the thing is, behind the scenes, less and less are attackers revealing that they found a vulnerability, especially if the website's very popular, like a banking or finance website or a very popular e-commerce website. When attackers find vulnerabilities on these websites, if you go back several years ago, they may have even ethically disclosed that vulnerability, but that is not the case anymore. If you have a vulnerability against a popular website, that vulnerability is worth a lot of money. And we see that attackers are selling these vulnerabilities on open markets for a significant amount of money. Definitely. Just in the last year, we saw a significant amount of denial of service attacks against the U.S. banking sector and other banking sectors around the world. And very few banks were able to withstand the attack from these denial of service attacks. They're of course, DDoS, distributed denial of service, where denial of service attack traffic comes from many computers all at the same time. And the problem is that with the last round of attacks against these banks, the most popular and powerful services were not able to stop these attacks. The attacks had so much traffic, used so much bandwidth, that even some internet backbones, like internet service providers who were providing the raw internet connection to these web servers, could not handle the attack. So it's not just the companies who had trouble, it was the backbone internet providers who couldn't handle the onslaught of traffic. And over time, they figured out the attacks and were able to reduce the attack in many complicated manual steps. But the infrastructure is having difficulty handling the recent generation of denial of service attacks because they are so huge and take up so much bandwidth and come from so many different computers. If the attacker wants to, he can take your site down. I agree with that 100%. It's not something that we'll ever be able to solve completely. Now, what we can do is, once the attack begins, we can start taking action to reduce the attack. But if you have a web server and you only have a limited amount of bandwidth that you can handle, and attackers can use relatively inexpensive techniques to send a mammoth amount of traffic against your web server. And very often, these are not like attacks per se. It's just a legal request. I'm just hitting the banking website's homepage with a lot of requests. And if you send enough requests in, you'll be able to shut that website down. There are certain attacks that are specialized where you may manipulate the HTTP request to not complete, or you may submit a form but be very slow in how you send out the bytes of that form request. And there's a whole list of other specialized attacks that attackers use in addition to just sending a lot of traffic in, and these are difficult to stop. Some of the most secure and well-funded websites in the world have fallen victim to denial of service even in the last year. So again, the best companies, even if they can't stop a denial of service attack, they can at least react to it after the attack has started and minimize how long their service will be down. Well, denial of service is a very special attack because, again, it's not even necessarily malicious traffic. With other attacks, we see that it's an attack. We see its signature in that request that has attack data in the traffic in some way. But and even if we don't see the attack inside of the request, we can still build a web application or a web service or a mobile app in a way that has the defenses and controls built into the application. The problem with denial of service and distributed denial of service is it's not necessarily an attack. It's not necessarily like something that we can detect in the request. It might be a completely legal request just done many times by many users all over the world, and suddenly the site begins to go down. So it often can be difficult to detect this kind of attack until it's too late and your service begins to go down. There are services like Prolexic and other services that will try to make it more difficult for your infrastructure to be denial of serviced. But if there's a limited amount of bandwidth and if enough users show up with a request, your site will begin to have performance problems or go down. And for smaller companies, it might be too expensive. It might be prohibitively expensive. Now, what they can do is leverage cloud-based infrastructure. You can always go to the different infrastructure as a service companies or the application provider as a service like the Azure Cloud and Google Apps. But suppose you're using that and you're paying per hit, and you pay per use, depending on how many users use your app. Then as an attacker, I can just hit your cloud-based hosted application and just hit it frequently to make your bill to use that service go up. But the attackers can leverage the fact that a company is using a cloud and make them incur usage costs that they never expected or never really should have incurred in the first place. Well, it depends what your goal is. If your goal is privacy, you better believe it. The social media networks have a mixed security history. And so when I use social media, I pretend it's public. Like I pretend whenever I post to social media, regardless of who the service is, I pretend that everybody in the world can see it. It's completely public information, and even if my account gets hacked, the damage to me personally will be minimal. And so I try to limit talking about my family. I don't put pictures of my family up, and I try to minimize how much secret information about myself I post to these social media sites. Many security professionals choose not to use social media at all. So it really depends who you are. But imagine using social network as a normal user for many years. And the amount of information you'll reveal about yourself over time, and pictures, and what your interests are, what your dog's name is, what your parents, eventually the profile that builds around you is incredibly detailed. And if the attacker may use this information to steal your identity, the attacker may use this information to compromise like different security reset password questions. So just treat social media as if everybody in the world has complete access to see everything in your account, and then you're safe. Let me put it this way. Information security is incredibly difficult. If any vendor ever comes to you and says, look, buy my magic firewall, put it in front of your web application, and all of your security problems will go away. Whenever a vendor tells you that, they are a liar. They are a liar. This is not easy. And next-generation firewalls, web application firewalls, look, it depends what problem you're trying to deal with. If you have a web application that's a very important part of your business, and you think that a web application firewall will solve all the problems that it may have, I don't think that's true. It will solve some of the problems. It will mostly solve only technical vulnerabilities and a few contextual vulnerabilities, but for the most part, a web application firewall is good at solving only technical vulnerabilities. So your business logic specific problems, they're not solved well at the firewall level. There's also a lot of web application firewall evasion techniques where different encoded attacks, or if the web application firewall is misconfigured, that we can circumvent the web application firewall or next generation firewall defense. So imagine if you have a very popular website and you update it many times a day. I know of some teams that update their website every half an hour or many times a day. And this is a not an uncommon technique in the world of agile development and DevOps development, which is the next generation after agile. So these teams, many of these teams are pushing new code live all throughout the day. And every time you push one of these changes live, you're going to have to change your web application firewall rules in some situations. So to run a web application firewall well, you need a dedicated full-time professional who's in sync with the software development and software release. Rules will change over time, and this is not easy technology. It takes a lot of work to run a web application firewall and run it well. So I don't think a company should ever think that they can just buy a web application firewall, slap it up in front of their web application, and all their problems go away. It is work. It is difficult. It is time-consuming. It requires specialized expertise to run well, and it's not like real remediation. It's just mitigation. It's not fixing the underlying problem. It's just adding a little bit of defense while that problem is still vulnerable. So, and here's the other side of the coin. Suppose you buy COTS, a commercial off-the-shelf software, or suppose you no longer have the code anymore, or suppose the application the developers who built the application are busy on other projects. There are certain times where you just don't have the time or the money to fix your underlying code. So a web application firewall can buy you time, can be a mitigating factor until you fix the code, or it can be the only choice you have for defense if you don't have the code or it's a commercial web application. I agree, and I break mobile security into two categories. Suppose I'm a team of developers or a developer who's trying to build a mobile application. That's one issue. And suppose I'm a company who's trying to manage all of my users who have phones. That's a second issue. Let me talk about the first one. How do I build a secure mobile application? Well, think about what's behind almost every mobile application. It's a web service. And so that web service is traditional web application programming for the most part. So all the same problems we have in the world of web applications, they apply to mobile applications, especially mobile applications that are networked enabled, which is the vast majority of them. And so developers need to be careful, like you just said. They need to be careful about saving sensitive data onto the mobile phone itself. They need to be careful about doing security in transit. They need to be careful about session management. But the rest of mobile security is very much the same as web application security. There's a couple things different or special things we need to look at, but I think a lot of mobile secure programming is a bit overhyped. A lot of the problems we face as developers to build secure mobile solutions, it's the same problems we've been facing in web application and other application security disciplines. The other issue about infrastructure mobile, it's not so much my expertise. That's the field of bring your own device and mobile management. That's a whole separate issue. Well, we should be concerned about it. I don't want my website defaced, and I know we see a lot of government sites getting defaced, and that worries me because that's a symptom of either cross-site scripting or content spoofing or deeper remote file inclusion attacks. So it's a symbol that the website is vulnerable in some way. I'm less concerned about the defacement. I'm more concerned about other more damaging attacks like the theft of sensitive data, the theft of personal information of the users, the being able to use a popular website to infect others with malware, or SQL injection, again, back to data theft or changing data, or again, that can lead to stealing of credit cards or stealing of finance information or stealing of proprietary information. These things worry me much more than a site-to-face